Hi folks, we're going to take a look at this question on the perpendicular bisectors of a triangle. Okay, so let's take a look at the question. So it says, using this triangle with vertices A, B, and C, we want to show that the perpendicular bisectors all intersect at the same point. Okay, so I think step number one is to remind ourselves what a perpendicular bisector is. Okay, so if I have a segment, so when we talk about a perpendicular bisector, it bisects a segment. Okay, so it's a line, first and foremost, okay, that cuts this segment in half and at a 90-degree angle. So in other words, you have to find the midpoint of that line segment, and then the line you're looking for is a line which cuts that one through the midpoint and at a 90-degree angle. Okay, so think about what you need to find a perpendicular bisector. Since it's a line, we need the equation of the line, and in order to find an equation of a line, we need the slope and a point. The point you're going to use is going to be your midpoint, and the slope is going to be the negative reciprocal of the slope of the given segment. Okay, so there's our algorithm for finding a perpendicular bisector. Find the midpoint, determine the slope of the given line, take the negative reciprocal, and then use the midpoint and that negative reciprocal slope to find the equation of the line you're looking for. Okay, we have to do this though 3 times because we're working with all the perpendicular bisectors in a triangle. So this is, we're going to see, is quite a long problem. So first thing is I'm going to draw a triangle that I'm going to use as a guide. I'm not going to use it to solve the problem, but just to guide me along. So let's start with 0, 4. Okay, so A is 0, 4. Now I'm not going to draw this on a Cartesian plane, but I'm going to try to make it reasonable here. So negative 2, 2, so it's going to be further to the left and further down. Okay, so we'll put point B here is negative 2, 2. Okay, and then point C, 2, so it's going to be further to the right, and 0, well, is between 4 and 2, so it'll be somewhere here. Okay, so again, I don't make an effort to really make it accurate, I just try to make it reasonable. Okay, and so we've got our triangle here, all 3 sides, and what we're going to look for is the midpoint to find the perpendicular bisector. We're going to do the same thing here, find the midpoint and then determine the perpendicular bisector, and then take the midpoint here, find the perpendicular bisector, and according to what they're asking me to show, these 3 lines should all intersect the same spot. Okay, so I'm not going to use my diagram to show that, but this is just my guide. Okay, so let's start with AB. So let's start by finding the perpendicular bisector. So the first thing I need is I need the midpoint between AB. So notice here, I always indicate with a subscript what I'm finding the midpoint of. Okay, so let's do that here. So we have x1 plus x2, so 0 plus negative 2 over 2. And then here we have 4 plus 2 over 2. y1 plus y2 over 2. Okay, so this is negative 2 over 2. Gives me negative 1, and this is 4 plus 2, 6 divided by 2 is 3. Okay, so there's our midpoint. Let's now find the slope of this perpendicular bisector. But in order to find the slope, I first need to find the slope of AB. Okay, so slope of AB is going to be y2 minus y1, so 4 minus 2 over x2 minus x1, 0 minus negative 2. So what does that give us? 2 over 0 plus 2 is 2. So there we go. The slope is 1. But what I'm looking for is the perpendicular slope of AB. Okay, the negative reciprocal, and the negative reciprocal of 1 is just negative 1. So now we can finally find the equation for the line AB. Okay, so here we have the perpendicular bisector of AB. So let's find that line. Okay, so equation of line, y equals mx plus b. Okay, I have a y value on this line. Remember, it passes through the midpoint. So it's going to be 3 is equal to the slope of negative 1 times the x value of negative 1 at that midpoint plus b. So what do we have? We have 3 equals 1 plus b. b is equal to 2. So that means that our equation here is y equals negative x plus 2. All right, so there's our first equation. So all that for just one of the perpendicular bisectors. So I'm going to do the next one a little more quickly, so I won't explain every single step, but you're going to see I'm going to do the exact same thing, so just follow along. So I'm going to do AC, so midpoint AC is equal to 0 plus 2 over 2 and 4 plus 0 over 2. Okay, so the midpoint is going to be 2 over 2 is 1 and 4 over 2 is 2. Okay, now I'm going to find the slope of AB. Okay, so here we have 4 minus 0 over 0 minus 2. So we have 4 over negative 2. So 4 divided by negative 2 is negative 2. And so the perpendicular slope of this is AC here. I just realized I miswrote it. So AC is going to be the negative reciprocal of negative 2 is positive 1/2. And so now we're going to find the perpendicular bisector of AC. Okay, so y equals mx plus b. Our y value is equal to 2. Our slope is 1/2, and our x value is equal to 1. So here we have b is equal to 2 minus 1/2. So just to make my life easier, I'm going to put everything over 2. So we have 4 over 2 minus 1 over 2. So b is equal to 3 over 2. Okay, and since this is a nice fraction, I'm going to allow myself to write that as y equals 1/2, which is our perpendicular slope, x plus, instead of 3 over 2, I'll just write it as 1.5, and I'll probably write that as 0.5 afterwards. Okay, and lastly, let's do now BC. So we start by the midpoint of BC, which is equal to, 2 plus negative 2 over 2, and then here 0 plus 2 over 2. Okay, so 2 minus 2 is 0, divided by 2 still 0, and here 2 divided by 2 is 1, and so there's our midpoint. Let's now find the slope of BC. Okay, so 0 minus 2 divided by 2 minus negative 2. So that gives us negative 2 over 2 plus 2 is 4, so negative 1/2. But of course we need the negative reciprocal of that for our perpendicular slope to BC. So the negative reciprocal of negative 1/2 is positive 2. Okay, and now we can find the perpendicular bisector of BC. Okay, so again, y equals mx plus b. Stick in y equals, well, actually, I just realized something. We don't really have to stick anything in because, hey, look, 0, 1 is on the y-axis. So that means that 1 is the y-intercept. We already know our b value. So we can just write y equals 2x plus 1. So that's sort of a special case that we happen to have the y-intercept already. Okay, so let's see what we've actually found. We've actually just found these 3 perpendicular bisectors. So our goal now is to show that they all intersect at the same spot. Okay, so let's say here we try to draw this. Okay, kind of looks like they all intersect there. So the question is do I actually have to solve 3 problems? And I don't think I do, because if I show that these 2 lines intersect at a particular point, and then I show that, say, these 2 lines intersect at a particular point, I don't actually have to show the 3rd one. I might do it just to sort of check our answer, but really it's enough to show that 2 sets of lines intersect at the same place. Okay, so let's start with our first one. So let's start with these 2 equations. Let's find their point of intersection. Okay, so I'm going to stick with y equals negative x plus 2, but I don't want to work with this fraction, so I'm just going to multiply both sides of this equation by 2, because then what happens? I'm going to end up losing that denominator here, so I'm going to do 2, let's call this 1, 2, and 3. So I'm going to do 1, and here I'm going to multiply equation 2 by 2. So what do we get? 2y. 2 times a half is just 1, so I'm just going to have x, and 2 times 1.5 is 3, so plus 3. And hey, look how nice that worked out. So I'm going to add these two equations, and what do we get? Well, we get y plus 2y is 3y equals negative x plus x is 0, which we anticipated, and 2 plus 3 is 5, so y is equal to 5 over 3. Okay, so there's our first value, and then let's find our second value. So let's stick this into this first equation here. Okay, so we've got 5 over 3 is equal to negative x plus 2. So I'm going to bring the negative x to the left to make it positive, and then here I'm going to have 2 minus 5 over 3. But to make my life a little simpler, I'm going to write 2 as 6 over 3. Bring this to the other side, minus 5 over 3, and my answer is 1/3. So my point of intersection here is x equals 1/3, y equals 5 over 3. Okay, so now our goal is to show that when I intersect any of the other two, I'm also going to get 1/3, 5/3. Okay, so let's do 1 and 3. Okay, so here I notice that the y's are actually both, the way I want them. They have the same coefficient, so I'm just going to take equation 1, which is y equals negative x plus 2, and then I'm just going to take equation 3, y equals 2x plus 1, and I'm just going to subtract them. Okay, so that I eliminate the y's. So y minus y is 0. Negative x minus 2x is negative 3x. And then 2 minus 1 is 1. Okay, and now we can solve for x. So I'll bring the negative 3x to the other side. Gives me 3x equals 1. And x equals 1/3. Ooh, look at that. Same x value. And now, well, I've kind of already done this work before, but let's do it again. Let's pick equation 1, and y is equal to negative 1/3 plus 2, but I'm going to write 2 as 6 over 3 instead, and so negative 1/3 plus 6/3 is, hey, look at that, the same point of intersection. Okay, still 1/3, 5/3. Okay, and just to be sure, as a check, let me solve the equation with 2 and 3. Okay, so here, let's see what I can do. I mean, you know what? Let's keep the fractions here because I like the y and the y. Let's do it a little differently this time. So I'll take equation 2. Okay, which is y equals 0.5x plus 1.5, and equation 3, which is y equals 2x plus 1. Okay, and let's do what we did in the last one, just subtract. So y minus y is 0. Here we have 0.5 minus 2 is negative 1.5x, and then here we have 1.5 minus 1 is 0.5, and let's solve for x. So bring the minus 1.5x to the other side. So we have positive 1.5x is equal to 0.5. X is equal to 0.5 over 1.5. Now, you can put that in your calculator, but I think you can see that this is just going to be equal to 1/3, which is exactly what we got before. And let's do what we did. So let's take equation 3. Y equals 2 times x, which now we know is 1/3, plus 1. So this is going to be 2/3 plus, and I'll write 1 as 3 over 3, so equal to 5/3. Okay, and so our point of intersection is yet again 1/3, 5/3. Okay, so we've managed to show that the intersection of the 3 perpendicular bisectors all occur at the exact same point. Now this is not just true for this triangle, this is actually true for any triangle. And I believe we already showed in class that this point is actually very special. It's actually the center of the circle which passes through all 3 points of the triangle, which we're going to talk about again. But just to recap here, step number 1, recall what it takes to find the perpendicular bisector. Do the work by finding the midpoint, slope, negative reciprocal slope, and equation of the line. And once I did that for all 3, I was able to show that regardless of how I found the intersection between any of the 2 lines, they all intersected at the exact same point. Okay, that's it for this one.